Okay, so this next section we're going to be talking about concentration, and concentration is basically how much solute is dissolved in a solvent. So how much solute in a solvent. Okay, two words that we'll talk about. If there's lots of solute in a solvent, we say that it's going to be concentrate or concentrated. All right, so if you go to the store and you buy orange juice concentrate, you don't eat it plain, you put a lot of water in it and then you dilute it. So if a solute has just a little amount of solute in it, a solution has a little amount of solute in it, we say it is dilute. Okay, and if you dilute something, you add a solvent to it. Or a lot of times we say we add water to it because water is called the universal solvent. Okay, so this next section is going to be doing problems with concentration. So numerically, how do we want to figure out concentration? There's lots of different ways. I'm going to explain all those to you, all right? So the first one right here, I'm just going to number them. Number one, I'm going to tell you what page I'm on. I'm going to be on page 375. I'm going to be doing example problem 12.5. Okay, so first of all, to do concentration, we do the first one. This one's going to be mass percent. So to do mass percent of a solution, mass percent equals the mass of the solute divided by the mass of the whole solution. Okay, not just the solvent. This is going to be the whole solution, and then we times it by 100%. Okay, so on problem 12.5, it tells us what is the mass percent of sodium hydroxide in a solution prepared by dissolving. So we've got 30 grams of sodium hydroxide that are being dissolved in 120 grams of water. Okay, so we're going to do our mass percent equals the mass of solute, which is 30 grams of sodium hydroxide dissolved in. Now remember, this is the whole solution, so we've got to go 120 plus 30 gives us 150 grams of our whole solution. So then we're going to go 30 divided by 150 and times it by 100, and that's going to equal to 20%. So we have a 20%, and we do mass by mass, mass of solute divided by mass of solution. That's how it is. Mass solution of sodium hydroxide. Okay, so we can do that. Now we can also, I'm going to do example problem. This is 12.6. The next one down. It says this one's going to be using a conversion factor like that 20%, using a conversion factor to figure out how much is in there. It says topical antibiotic ointment Neosporin Neosporin is 3.5% mass by mass. Neomycin solution. How many grams of neomycin are in tube containing 64 grams? So we've got 64 grams of the whole tube. Okay, so basically that 64 grams is a solution, right? So we have 64 grams of a solution that has 3.5%. Well, what we're going to do is we're just going to do a conversion factor here. Okay, so we do a conversion factor. 3.5% really means there is 3.5 grams of the neomycin in 100 grams of the solution, right? 100 grams of the solution. Okay, so a conversion factor, solution, cancel solution. So then we just go 64 times 3.5 divided by 100, and we have 2.2 grams of neomycin, if I spelled neomycin right. Okay, so that's how we can use a conversion factor. If we know the percent, we can just work it backwards from there. Okay, so the next one we're going to do, number 2, is going to be volume percent, and this is page 376. I'm going to do example problem 12.7, and this is a volume. So volume percent equals the volume of the solute divided by the volume of the whole solution. Again, remember we're doing the whole solution. So it says, sample problem 12.7 says a bottle containing 59 milliliters of lemon extract solution. So we have 59 milliliters of lemon extract. That's the whole solution. Okay, if the extract contains 49 milliliters, so it has 49 milliliters of alcohol, what is the volume percent of the alcohol in the solution? So we're just going to go right here. We're just going to go volume percent. So volume percent equals the volume of the solute, which is 59 milliliters. Then we're going to divide it by the solution. Now we're not going to add these two together because this already told us it was just solution. Whoops, I got that backwards. 49 milliliters of alcohol. Okay, divided by the 59 milliliters of the whole solution. And then we're going to times it by 100%. So we're going to go 49 divided by 59 and then times it by 100. So our volume percent is going to equal to 83% volume by volume of alcohol. Okay, the next thing we're going to do is this is number 3, and this one is going to be calculating mass by volume percent. So this is on page 377. This is going to be 12.8, and it says this one's going to be percent by this one's going to be mass volume percent. So this one's going to be, we're going to do the mass of the solute divided by the volume of the whole solution. And then times it, of course, by 100%. So mass by volume. So this one says potassium iodide solution may be used in a diet that is low in iodine. The Ki solution is prepared by dissolving. So we have 5 grams of potassium iodide in enough water to give a final volume. So our final volume is 250 milliliters, and that will be our whole solution. Okay, so because it tells us, it gives us a final volume, a whole solution right there. Okay, what is the mass by volume percent of the Ki solution? So we're going to do mass by volume percent equals, we have 5 grams of potassium iodide dissolved in a total solution of 250 milliliters, and then we're going to times it by 100 to give us our percent. So 5 divided by 250 equals a 2% solution mass by volume of potassium iodide. Okay, that's how we do that. So those are the different ways to express solutions or different percents of solutions right there. So you can look at things, you can look at hydrogen peroxide and it'll say 3% hydrogen peroxide by volume. Well, that means there's 3 milliliters per every 100 milliliter of solution. And so that's how you do concentrations.